Hi, I'm Chris Martin. I head up soil health for AgVista, and we're here today at Lamport. And what we're looking at today really is the backbone to how we actually start to manage some of these plots. And the best way to do that is to see what we've got to start with a comprehensive soil test. And what we've got here, we've got a chemical, physical and biological example of the AgVista Gold Soil Health Test that's really helping us make some informed management decisions to help drive soil health forward and improve the overall soil functionality. So the key things here from Lamport is, if we start with the chemical, we've got a very high pH, which is very much dominated by the calcium. And that's going to really affect the way we have to manage this soil when it comes to nutrition. So we need to make sure we're using the right products at the right time and the right type of products to stop them being locked up and made unavailable by the high pH and the high calcium. And by having an overview of every product, we can start to get an indication of which products are going to be, of which nutrients, are going to be more available, which ones are going to be antagonistic to others, and so we can actually start to match nutrition to need. And if we back this up with tissue tests throughout the season and then an overall grain test at the end of the season, we can make sure we're getting the best value for our nutrition for our growers. So what we're looking to do here is plan with this overall soil test, then monitor throughout the season with tissue tests, and then finally review at the end of the season with a grain test. And then we know we're getting the best we can possibly do from a nutritional point of view. The other advantage of a broad spectrum soil test is we can also start to get some other useful properties. For example, here at Lamport, we can look at the physical properties, and we can see here one of the key things is we've got quite a high calcium to magnesium ratio, which means this soil is likely to flocculate, which is quite a good thing because it's bringing air back into this soil and helping to self-structure. The problem here at Lamport, we've also got a very, very high silt content, which means we've got lots of fines in the soil, and these fines will start to run and move in the soil. So with the high calcium and the high silt, this soil is very, very prone to slumping. And that's really going to have a major influence on how we manage this soil when it comes to cultivations. So we're often going to need some form of tine in our rotation to get some oxygen back into the soil to try and get the biology going. So some really key management decisions on what sort of drill we should use here and what sort of cultivation we should use here, all from this soil test. And then finally it comes to biology. Something that the industry is talking about a lot at the moment is how do we measure biology? And one of the things we can think about a soil test when it comes to chemical and physical attributes, if you do a chemistry test at school, you generally get the same answer time and time again. It's repetible and it's meaningful. Biology is something completely different. It's a living, breathing medium, and it's very, very difficult to get anything meaningful and repeatable. So what we're looking at here is indicators. Some indicators we can use to make informed management decisions to help drive that soil functionality forwards. So to start with here, we look at organic matter. And the key thing at organic matter here at Lamport, it's actually at 3.9%, which is reasonably good, you would think, in a standard organic matter. But the potential here at Lamport is so much more because of the high clay content. And when we actually look at comparing the organic carbon to the clay content, here at Lamport it's classed as degraded. So there's lots of potential to try and drive that organic matter forwards here at Lamport, which will help buffer some of these issues we talked about with this slumping. So one of the key things we need to do here is bring organic materials in here. And the beauty of Lamport, it's the carbon nitrogen ratio is fairly well balanced, as you can see on this side. So really any cover crop or any organic material we bring in is going to be beneficial. On a lot of farms we tend to be in balance. We're either got a low carbon nitrogen ratio at this end or a high carbon nitrogen ratio at this end. And what we tend to find there is rather very dynamic, so we're turning over lots and lots of carbon and lots of nutrients, but not building up long-term organic matter at this end. Or at this end, where we're a high carbon nitrogen ratio, it's almost like our soil is constipated. We're not getting the value for our organic material. So we need to make sure what we bring in balances our soils. So here at Lamport, we can bring in anything because we're already balanced. On a farm back home, you may need to start to think of what is the best organic material to help balance them soils. Having known what we're actually doing with our organic matter, then we can start to look at soil biology. And there's lots of tests for soil biology. Here at Lamport, we've gone right through to species identification. And what that actually found is we've got lots of species in the soil that are yet to be identified. So from a practical point of view, pretty meaningless really. But from a practical point of view, what we're looking at is the soil respiration test, because we call this the canary in the mine. It's a really good indicator that you've got good or bad biology in the soil. And if that's lower than expected, what it tends to suggest, you've got some problem which you might go and investigate with a spade and see what's wrong here. So here at Lamport, after 8 years, our respiration is getting quite good. We're in a reasonable place here, so when we do a respiration burst, we're capturing quite a lot of carbon. But can you have too much of a good thing is one of the arguments with the respiration test, because essentially it's a measure of carbon dioxide. So if you're capturing a lot of carbon dioxide, that could be lost from the system. So we'll always combine that with an active carbon test. And an active carbon test is really designed to measure the freshest forms of carbon, the root exudates, etc. And there's a good correlation between a short-term active carbon figure and the long-term build-up of organic matter. So it's telling us in 20 years' time, if we've got a good active carbon, the chances are our organic matter will be rising. So a really good indicator. But also when we combine that alongside the respiration test, it's telling us if we've got good respiration and active carbon, we've got lots of microbiology, so there's lots of stuff going on, breathing and living in our soils, which is great, but we're also capturing that carbon in the cycle and keeping it in the system. If one of these is low, it's telling us we might need to make some management decisions to try and alter it and influence it to improve this long-term soil health and functionality. And last but by no means least, from this we can get an idea of how much carbon we've actually got in the soil. So carbon dioxide equivalents here at Lamport, we've got 162 tonnes of CO2 equivalents in this soil, which is giving a good indication when we go forward for looking at the future with carbon. So overall, by looking at chemical, physical and biological indicators, we can get some really good management decisions how to drive this farm forwards and really let us know the sort of canvas we've got to work with.